All right, let's start looking at this. What's the claim that number 6 is making? Now be careful, we never have to make a claim about the sample stuff, because the sample stuff we can see, right? We make a claim about the stuff we can't see. We make a claim about the whole population stuff. So you'll never see p hat here, you'll never see x bar here, right? So this is going to be that the mean of the first group equals the mean of the second group. I like it. And which one's that going to be? The whole. I like it. So the high is going to be not equal to. So it's going to be a 1 or 2 tail test. 2. I like it. So I'll help us out on step C. Sort. Do I use a z-score or a t-score? And why? T-score. Why? Yeah, 1, don't know sigmas. 2. There's always 2 things you got to tell me. Why is it normal?
More than 30.
So you get, oh yeah, that's not more than 3. I forgot which one we were doing. So the sample sizes are not big enough. One's like 16, the other one's 14, right?
Yeah.
What is it that saves us? It says it's normal, right? So we know normal population, check. All right. So you just got to say it's normal, or the sample size is going to be large enough if you're dealing with means, or NP, NQ's got to be bigger than 5 if you're dealing with percentages. Degrees of freedom, I'm using a slightly different formula than the book. A lot easier formula. So it'll be, what is it, 14 and 16, right?
Yeah.
Minus 2. So that's 28. I like it. So you got a degrees of freedom 28, alpha's 0.05, 2-tail test. So what will the t-score be?
1.701.
So you guys got 1701? So it's 0.05, 2-tail test. Degrees of freedom 28. Yeah, 2.048. See that, Travis? If it was a 1-tail test, it would have been good. So this is a little formula I gave you guys in class. It's just easier, it's just accepted. The one they use in the book is a little more precise, but it's just overly cumbersome. We don't need it.
Is that on Monday?
We did the last time, yeah. Yep. So if T star is what? Less than negative or greater than positive 2048, we can reject the null. Support the alternates. Always, you either reject the null or fail to reject the null, which means you support the high or fail to support the high. There's only 2 things that can happen. So there's all the sample data analysis, right? So now you just got to throw all that to the formula in the right place, and then put the formula in your calculator correctly. So T star would be 7.63 minus 5.07 divided by square root. And the place where people mess up, wow, Joe, that was extreme. The place where people mess up is they forget the square on those S's. calculator like that. Let me see, let me do it with you guys. Do it live. What do you guys get? I love you. Sing it. Do it, do it. It's almost what I got. Yeah, I don't know if you use 7.6 or something. I got like 4.7. I got 4.70. So if you use a different number, because I didn't tell you how far to go out, you'll get something close to that. So 4.7, whatever you say. 4.7. What does that mean? Yes, ma'am.
How did you put that in the calculator? Because that's what I put in the calculator.
Let me see. Oh, you put 1.46 instead of 1.46. See how?
Oh.
Yeah. So what's that mean? Where did it fall? Yeah, it fell into the rejection. It fell way into the freaking rejection. What do you have there? Those means are really far apart from each other, relatively. All right, now on the first day of class, if I would have asked you, is 7.63 really far away from 5.07? You would have naively said, no, they're really close together. But now we understand the idea of distance in statistics is related to the standard deviation. So according to that, these are really freaking, they are almost 5 standard deviations apart. So what's more likely, that they are actually equal and we just happen to pick samples that were really far apart, or that they're not actually equal means? Kind of. With my tone, I led you in the direction. Yeah, what's more likely is the means are not actually equal. Right? What does it mean? We can reject the null. We can reject that the means of the populations are the same. Because we took 2 samples and the sample means were so freaking far apart that it is more likely that the population means are different than we just happen to pick samples that were really different. Yeah, I like it. So we can reject the null, support the high. So, well, our conclusion. We have, yeah, no, did we make it or not? We made it, so we didn't fail. We have found sufficient, and which one of these are we going to use? Which one? The claim was the, oh, we have found. I was saying to myself in my head, we have found the promised land. We have found, I started right, sufficient evidence to reject. Right? Why are we using the word reject? Because the claim is the ho, and which language goes with that? Reject. There's no ambiguity. There's no shit, I'm just going to take a guess. We found sufficient evidence to reject the claim that what? That the mean, what was it? Study time? I can't remember what it was. Sure. Yeah. Mean study times for those who passed and those who failed. Are the same. Which you kind of would expect. Take a group of people who pass the course and a group of people who fail the course, you'll probably find some stark differences in their study habits. That doesn't mean that everybody in both groups follows that pattern. It just means, as a whole, there are differences. This would be one of them. This is based on something I did a few semesters back on a survey I made. All right. Is that? I mean, that's just like almost every hypothesis test we've done. It feels like every hypothesis test we've done. It was just a little more work because I didn't give you everything you needed here. You had to put this in your calculator. But every step is the same. Every step, thank God, is the same. It's the same steps. They don't change. Thank God. Just to remind you guys again, the book is going to ask you to use whatever format they have in the back of their book. Screw that. Do this. Because this makes more sense for those of us who are doing it correctly, i.e. by freaking hand. Right? Okay. The book kind of starts with the answer because you just pick it out of your calculator. Some of you guys are like, if I have to take this over, I'm not taking you again. Screw you. I'm going to find one of the calculator people. Let me push some buttons. All right, that's up to you. All right. Anything else from the practice test or homework that you want to look at?
I have a question.
Yeah.
What's type 1 and type 2?
Oh, yeah. Okay. All right. So here, let's talk about this. Well, all right. Let's say, in general, what is a type 1 error? When you do what? Uh-oh. It's a shorter phrase. So what can we do? What two things? There's only two things we could do as a result of a hypothesis test. We can reject the null, or we can fail to read it. Now, when would it be a mistake if we thought this guy was wrong? If we reject this, when would that be a mistake? When in reality, this is true. So when is it a mistake? When we say, oh, I reject this, and in reality it's true. Like that's, please. Do you get that? That's why it's an error. Okay. If I say this is wrong, if I reject the null, when would that be a mistake? When this statement is in reality true. So, didn't we reject the null? Yes. Does that mean definitively that this is not true? No. We got really good evidence that it's not true, right? But they have really good evidence for people on death row that come to find out they didn't do it. You see, so the really good evidence part is nice. It makes us, oh, it's really good evidence. But it doesn't mean that it's definitely the case. You guys follow? Okay, cool. Maybe. So, okay, what does that mean practically? So type 1 error would be, that is actually true, but we find evidence that it isn't. So how do I put that into actual English? Because that's the answer to this question has got to be in English. Let me take this away. So type 1 error for this problem would be, you can say this a couple different ways, but you can say, I'll just start with, the means are actually the same. But we think they are different, or they are not, whatever way you want to say it. Or it could be more precise and say, the means are actually the same, but we found evidence that they are not the same. I'll take whatever way, as long as you capture the essence of what it means to be type 1 error. And just the idea is it's a mistake, it's an error. So when you word this, you got to say, there's got to be somewhere where you go, well, that was wrong, that was a mistake. I love you guys. So if this guy thinks they're equal and we think they ain't equal, in reality they are equal, then shit, we made a freaking mistake. And in reality, you never know if you made the mistake. You can only control the probability that you make this kind of mistake. That's all you can control. Do you know when you made a mistake? No. Not until something blows up or somebody died. Yes?
This only applies to them being equal.
This applies to whatever the host says. In this case, the host said this. So that's how I word my type 1 error stuff. Like, what would a type 2 error be? Well, it's got to be the opposite problem. And what's the only other thing? I could either reject it, and it's a mistake if it's actually true, or I can fail to reject it, and that would be a mistake if this is actually false. So the means are not the same, but we think they are the same. Yes, maybe?
Well, this applies to this problem.
Yes, because that's the hope. So in your homework, I think the problems where they ask you the errors, you should sit down and write the HO. Make sure you can write the HO, because then that's what you're going to reference. They don't give you the HO, they give you a claim, I think. Then you write the HO and the H1, and then you can reference the HO in your error statement. Or just put something down and hope I don't look at it. All right, so that's a good question, because the types of errors are kind of a weird thing. But type 1, reject a true. Type 2, fail to reject a false. That's how I keep it in my head. Type 1 is a short statement, reject a true. Type 2 is fail to reject a false. Oh, sure. That's how I keep it in my own head. I like it. It might keep. Okay. Anything else specific or general questions? Or yes?
I think it was homework chapter 8, question 130.
130?
Yeah.
$131, okay. Oh, good. Yeah. So this relates to, if you've done it, this is the same kind of problem, at least to start with, as number 102. They give you a confidence interval, and then they ask you what's the point estimate, which is another name for the sample mean or percentage. The point estimate is our best guess, which is the sample information. So this is a lot nicer than the one on 102. If this confidence interval, what's always right in the middle of a confidence interval? No. No, I'm not sure who said that, but does the confidence interval always catch the true mean? No, in fact, that's part of the whole idea is if you will make a 95% confidence interval, then you're 95% confident that your interval catches that. I mean, there's always a chance it doesn't catch that. But what is always in the middle? How is it built? What's the formula for, like, let's do a p-hat one, because this is a question. P-hat plus or minus. Who cares, right? But what's going to be in the middle then? If I said 7 plus or minus 11, do you have to do any work to tell me what's in the middle of that interval? You shouldn't. It's 7, right? 7 plus or minus 11. What's in the middle? 7. I don't do any work. Screw the work. I have 7. Now this sucks because they gave me, somebody did the work. Now I got to go, oh shit. All right. So they tell me it's 49, what was it? 49% to 55? Yeah. All right, well, what's right in the middle? So what I do is I actually find the error. First, how wide is this? 6. So what's half of that? 3. Won't that get you right to the middle? And isn't 3% then the error? That's how far away from the middle each side is. So the error is 3%. And what's 3% up from 49? 52. And isn't that 3% away from 55? Do you guys see that? That's the problem. If I worded it differently, I could have given you that problem back in, Math 90, Math 110. It's just playing what's in the middle. And then how far from the edges is it? That's really all the question is. It's not really a stats question, to be honest. So p-hat would be 52%. That's right in the middle. That's the first question. Oh yeah, I like the rest of this. So can we conclude, allowing for the amount of confidence, we know it's not 100% confident, but according to this, can we say that more than half do whatever? For sure. Why can we not? What do you think? If my confidence interval showed evidence that it was more than half, then what should not happen? My confidence interval should not include. If If I say the boys were aged 7 to 14 that came in there, were they all older than 8? No. So is this evidence that it's more than 50%? No, because it includes the chance that it's down to 49%, right? So this is not evidence of something being more than half because it includes the chance that it's less than half. Do you guys see that? That's what that question is really all about. When you make a confidence interval, you can then, it's sort of a, it's not as good as a hypothesis test for checking claims, but you can still use it to start to check a claim. You have to follow it up with the hypothesis test to really be sure. But this looks like evidence that you can't say it's more than 50% because it includes the chance that it's less than 50%. Then they ask you to redo a confidence interval at a lower level or something. Yeah, only 75% confidence. So if it was instead 51% to 53%, does that show evidence that it's more than 50%? Yes, because it doesn't include the chance that it's even 50%, right? But if this is only 75% confidence, I'm not going to report that, right? There's a 25% chance I'm wrong. Screw you out. I don't like that. Okay. So it's the kind of question I really like to ask, and I think I asked this before. If men's interval went from 11 to 17 and women's interval went from 18 to 24, is this evidence that they're not the same, that the means of the two groups are not the same? Does this allow for the possibility that they are the same? That's another way to say the same thing. What does this guy seem to say that it could be at most? What does this guy seem to say it could be at least? 18. So could they be the same according to my findings? No. Is there a chance I'm wrong? Oh, hell yeah. If I made a 100% confidence interval, it would always be this, which doesn't tell you shit. So that's why we don't like it. Maybe. So what would have to happen in order for this to not be evidence that they're different? Or in order for this to be evidence that they are the same, these two would have to overlap. Then it allows for the chance that they're the same. This does not allow for the chance they're the same. It's evidence that they're different. So confidence intervals are a quick way. So you don't do a whole hypothesis test. It's just a quick, low-level amount of evidence that something could be the same or looks like it's different. Right? If you really wanted to be fully clinical about it, you have to do a full hypothesis test. I made you do that on something. It was a handout or something we did in class together. I did. Just nobody remembers. It's okay. I do all this work. Yes?
10.1.
Okay. Sure. Let's see. So this one, let me just collect what it tells us. So it says a recruiting office thinks that the mean mechanical engineering salary is lower than the mean electrical engineering salary. Just be on the face of it, seems like it might be true. So let's call mechanical engineering me first. So we'll call the me's the population 1. And we'll call the E's population 2. Mechanical engineering, electrical engineering. And they just tell me straight up. They don't give me a list of data like mean old Waller does. So let's see, they surveyed 50 mechanical engineers, N1 is 50, and 60 electrical engineers, N2 is 60. There's absolutely no problem with these being different. Zero problem with those being different. Their mean salaries were $46,100 and $46,700. Standard deviations were 3450 and 4210. Conduct a hypothesis test to determine if you agree that it is lower. So the claim is that that is less than that. So this is basically just like the one we did, number 6. Right, it's going to use that beefier Z star, or T star, whatever you call it. You guys with me? Because there's 2 samples. So whenever there's 2 samples, it's going to have to be the larger Z-score formula. That's all. Well, which one is this going to be? HO or H1? This claim. Yeah, it's going to be H1 because it doesn't have equal. So the claim then would be what? Exactly. I mean, the H1 would say what? What symbol are we using? Because we're talking about means. So it'll be U1 less than U2. Now, if you call these 1s and these 2s because you want to be an electrical engineer and you're like, number 1, then your H1 will be greater than, your tail would be on the other side, but the C-star formula would have them turned around also. So if you think about it, as long as you keep everything set up straight, it doesn't matter which one you call 1 and which one you call 2. It shouldn't. All the formulas kind of turn around for you. Keep everything in the right place. All right, so that means HO would be, even though the book says equal, screw that. 1 or 2 tail test? 1 tail. Okay. And then you got to do, obviously, which one am I going to use? C or T? T? Why am I allowed to? Say again? Yeah, so that's why I have to. So T scores, sigma's unknown, and the n's are bigger than 30. I like it. Cool. So we got to use T-scores. And then the third thing, now that I know I have to use T-scores, I know it's a one-tailed test. Do they tell me an alpha? No. So then what alpha do I use? Yes?
When do you put
I don't think they do.
N1 and N2 is less than 30, and then when do you put it if it's less than 5?
Greater than 5. What does the greater than 5 relate to? Tests about percentages. So, and yeah, exactly.
Okay, but in this situation, you would put
So anytime it's about means, it's about the sample size being bigger than 30. Anytime it's about percentages, NP and NQ have to be bigger than 5. I just wish you guys remember, it's just because I want to pull that histogram away from each wall so it's got room to go up and down. That's what the NP being greater than 5 and the NQ being greater than 5. It keeps it away from the walls so it's got room to go up and down. That's it. That's all that one means. So then third step, rejection region. So one tail test, where's the tail at? Yeah, it's down here. Why? Because there. It's pointing that way. So yeah, it's over there. I like that. So can you guys, what's the degrees of freedom going to be here? And you know, what are we going to end up having to use?
50 or 60.
Yeah, 50 plus 60 minus 2, which is 108. So we're going to use 100 because that's the closest thing to it that's below it.
So if it were to be like 199, would we still use like 100?
No, when you get up to that point, if you use 200, that's fine. They change so little once you get above into the 100s that's acceptable. I like it. You're looking at me like, okay, where exactly? Well, it's sort of like the word large. It's really up to you. So if it's 108 and you go up to 200, no, I'm going to do something. If it's 150 around there somewhere, I can understand going up to 200. Okay.
What's alpha?
To be perfect, we use technology. If we use technology, we don't learn. So we're okay with not being perfect because we'd rather learn shit. After you learn it, you can do whatever the hell your job wants you to do. I don't care. I just want you to know it before you start pushing buttons. Okay, so can you guys... Yeah, what's alpha going to be? If we don't know, we always use 0.05.